Hello guys, welcome to my channel. Myself Vikas Araj. I am doing my engineering in SVCE college. Today's topic is about the batteries from the subject of applied chemistry. Batteries and fuel cells. In 1800, the first battery was invented by the Volatic Pile. Next in 1821, the first electric motor. And next in 1835, the first BEV, full form of this work, battery electric vehicle, was invented. In 1839, first fuel cell, which was invented from the gross gas battery. Batteries. They are electrochemical cells connected in series. Batteries are storehouses of electrical energy. They are used as a source of direct electric current at constant voltage. They are classified into two types, primary cell and secondary cell. Primary batteries. These are non-rechargeable and are meant for single use and discarded after use. Secondary batteries. Voltaic cells whose electrochemical reaction can be reversed by a current of electrons running through the battery after the discharge of an electrical current. A secondary battery can be restored to nearly the same voltage after a power discharge. Primary cell. In this cell, the reactions are irreversible. It is also known as dry cells. At anode, it contains zinc container. At cathode, it contains carbon rod. Anode reaction, zinc is converted into zinc 2 plus 2 electrons are liberated. Cathode reaction, 2 ammonium plus 2 magnesium oxide plus 2 electrons give rise to ammonia, magnesium oxide plus ammonium plus water. Cell reaction, magnesium oxide plus ammonium chloride plus zinc converts into a ZnNH3 twice Cl2 plus magnesium oxide plus H2O. Lead, lead storage battery. At anode reaction, lead plus hydrogen sulfate gives rise to lead sulfate plus H plus 2 electrons. At cathode reaction, lead oxide plus hydrogen sulfate plus 3H plus 2 electrons gives rise to lead sulfate plus with water. Overall cell reaction, lead plus lead oxide plus 2H plus 2 hydrogen sulfate gives rise to 2 lead sulfate plus 2 H2O. Lead acid recharging. Low self-discharge, no memory, cannot be stored when discharged, limited number of full discharges, danger of overheating during charging. Applications. Automobile and construction equipment, standby or backup system for engine batteries. Advantages. Low cost, long life cycle, ability to withstand moisture treatment, perform well in high and low temperature. Lithium ion battery. It is also called as Li-ion batteries. Li-ion batteries are secondary batteries. The battery consists of an anode of lithium dissolved as ions into a carbon. The cathode material is made up from lithium liberating compounds, typically the three electroactive oxide materials: lithium cobalt oxide, lithium manganese oxide, lithium nickel oxide. This picture shows about the principle of the Li-ion battery. Advantages. They have high energy density than other rechargeable batteries. They are less weight. They produce high voltage out about 4 volt as compared with other batteries. They have improved safety. Example, more resistance to over voltage. No liquid electrolyte means they are immune from leaking. Fast charge and discharge rate. Disadvantage. They are expensive. They are not in standard cell types. Applications. The Li-ion batteries are used in cameras, calculators. They are used in cardiac pacemakers and other implantable devices. They are used in telecommunication equipment, instruments, portable radios, and TV pages. They are used to operate laptop computers and mobile phones and aerospace application. Fuel cells. These pictures show about the flow batteries of the fuel cells. Fuel cells. The cells that converts energy of combustion of fuels like hydrogen, methane to electrical energy. Different fuel cells are the direct conversion of chemical energy to electrical energy as 100%. The cell representation is as follows: fuel, electrode, electrolyte, electrode, oxidant. Types of fuel: hydrogen oxygen fuel cell, methanol oxygen fuel cells. Limitations of fuel cell: large weight and volume of hydrogen gas fuel storage system, high cost of hydrogen gas, technological advances should bring the cost down, lack of infrastructure for distribution and marketing of hydrogen gas. Most basic fuel cells suffer from carbon dioxide leakages and should be prevented from entering the cell and reacting with the electrolyte. Hydrogen oxygen or alkaline fuel cell. In this fuel cell, electrolyte is 25 to 30% aqueous KOH. These cells make use of high purity of hydrogen as fuel and oxygen as oxidant. The reaction between H2O2 takes place to produce water, and excess electrons produces the electric current. Reactions at anode 2H2 plus 4OH gives rise to water. and oxygen reaction with the water give rise to OH minus. Net reaction is the 2H2 plus O2 give rise to 2H2O. The product discharged is water and standard EMF is 1.23 volts. Application. These are used as auxiliary energy source in space, vehicles, submarines and military vehicles. The product in the cell is water. Methanol oxygen fuel cell. In these cells, CH3OH is used as a fuel and O2 as an oxidant to generate electric current. This cell has two electrodes. Porous nickel electrode coated with PT or PD catalyst acts as anode and coated with silver catalyst acts as cathode. The electrolyte KOH taken is in between two electrodes. These are the reactions and advantages of these are these cells are reasonably stable at all environmental conditions, easy to transport, do not require complex steam reforming operations. Thank you for watching my video. Please like, subscribe and share.